This is a walking talking mock for Chemistry 2. It's a higher paper from June 2015. The paper is 60 minutes long, so 1 hour, and the total mark is 60 for this paper, so it's roughly 1 mark per minute. Question 1. A student investigated the rate of reaction between calcium carbonate, marble chips, and hydrochloric acid. The student used the apparatus shown in figure 1. So, have a look at this figure quite carefully. We've got a conical flask that contains calcium carbonate or marble chips and the hydrochloric acid. There's then a bung and a delivery tube that goes into a water trough and up into a measuring cylinder. And then we can see that the gas that's being collected is carbon dioxide. The student recorded the volume of gas collected every 5 seconds. Repeated the experiment using hydrochloric acid at different temperatures. The equation for the reaction is CaCO3 in its solid state plus 2HCl, which is aqueous, gives you calcium chloride, aqueous, plus water, liquid, plus gas, which is CO2. Question 1a. The student plotted results for the hydrochloric acid at 20 and 40 degrees C on a graph. Figure 2 shows the student's graph. So here we've got the x-axis is the time in seconds and the volume of gas on the y-axis. We've got curves for 40 degrees and 20 degrees. Use the information from figure 2 to answer the questions. So we're specifically looking at information from the graph for this question. State one conclusion the student could make about the effect of temperature on the rate of reaction. So if we look at our graph, we can see that as the temperature increases, the rate of reaction increases. You could also have at 40 degrees, the rate is faster than at 20 degrees. Okay, so next question. Give one reason why the student could make this conclusion. Now here you need to look at the graph. So specifically looking at the graph, we can see that the 40 degree C curve is steeper. So that means that the reaction rate is faster. And you could also have that the 40 degrees C line finishes sooner. The reaction finishes sooner because it becomes horizontal quicker. Question 1a3. For the hydrochloric acid at 60 degrees C, the student had collected 30 centimetre cubed after 15 seconds. Calculate the average rate of reaction from 0 to 15 seconds. Now a big clue to what you need to do here is in the units. If you've got centimetre cubed per second, find your centimetre cubed and find your seconds. And that per second there means a divide. So the reaction rate is going to be the 30 centimetre cubed divided by 15 will give you 2 centimetre cubed of gas every second. So the answer there will be 2. Question 1b. The student then investigated how the surface area of marble chips affected the rate of reaction. Which 2 variables should the student keep constant? Okay, so here we are wanting to keep constant the concentration of the acid and also the mass of the marble chips that we use. Question 1b2. Explain in terms of particles and collisions the effect that increasing the surface area of the marble chips has on the rate of reaction. Okay, so if we've got a bigger surface area, then we have more particles that are exposed and that can react at any one time. So this means that it increases the rate because there are more frequent collisions between particles, and those particles are able to successfully collide to create a reaction. Question 1c. Calcium carbonate is a catalyst for the industrial production of biodiesel. Give one reason why using a catalyst reduces costs. Right, there's a few things you could put for this one. So you could have it increases the rate of reaction, it reduces the energy required, a lower temperature can be used, and the catalyst is not used up itself. So any one of those will give you 1 mark. Remembering as well that a catalyst reduces the activation energy. Question 2. A student investigated the temperature change when zinc reacts with copper sulfate solution. The student used a different concentration of copper sulfate solution for each experiment. The student used the apparatus shown in figure 3. So you've got a thermometer, glass beaker, copper sulfate solution, and in there you've got some zinc. The student measured 50 centimetre cubed of copper sulfate solution into a glass beaker. He measured the temperature of the copper sulfate solution, added 2.3 grams of zinc and measured the highest temperature. Then repeated the experiment using copper sulfate solution with different concentrations. The equation for the reaction is zinc, which is solid, plus copper sulfate, which is aqueous, gives you copper, which is solid, and zinc sulfate, which is aqueous. The thermometer reading changes during the reaction. Give one other change the student could see during the reaction. Now, again, there are a couple of points you can put here, but there's only 1 mark. So you could have solution becomes colourless, zinc becomes bronze or copper coloured, the zinc gets smaller, or bubbles or fizzing can be seen. So any one of those will get you 1 mark for this question. Question 2b. Suggest one improvement the student could make to the apparatus in figure 3. Give a reason why this improves the investigation. So there's 1 mark here for the improvement and 1 mark for the reason. There's 2 improvements you can have here. The first one would be to use a plastic or polystyrene cup and add a lid, and the reason would be there because it stops heat loss. And the second improvement could be to use a digital thermometer, and it's because it gives you more accurate or more easy to read data, and it also will store the data for you. So you must remember, whichever one you choose to do, you must state the improvement and the corresponding reason. Describe and explain the trends shown in the students' results. Okay, so for this one, you've got to use the data that you've been given, but you've also got to be able to explain the science behind it. So some examples of linked statements that you can make are temperature change increases as concentration of copper sulfate increases. The temperature change increases and then remains constant. And after experiment 7, the temperature change remains constant. You can also include that the reaction is exothermic as it is given off heat. More data that you could add in is that the trend starts to change at experiment 7 and that experiment 3 is showing an anomalous result. And those points altogether will describe the trends shown in the results. Questions like these, you need to make sure you use as much data as you can from what you've been given. Next, we need to explain the trends. So, what we need to say is that temperature changes and increases because the rate increases, and then the temperature change levels off because the reaction is complete. So as we add more copper sulfate, more heat energy is given off. Once the copper sulfate is in excess, there is no further heat energy produced. And all those points together, so the description and the explanation, should get you the full amount of marks for this question. My advice would be to you when you are doing these, if you can't write it up in a flowing sequence to get the quality of written communication, then just bullet point it. Bullet point as many things as you remember about the topic. Okay, so get the information down. Don't ever skip a 6-mark question. Try and get anything you know about that subject into there. Question 3. This question is about metals and alloys. Explain how electricity is conducted in a metal. To gain 4 marks, you must include a description of the structure and bonding of a metal. To answer this question, you need to start by talking about the metal structure. It's a giant structure and it's organised into layers with the atoms closely packed together. Now you can take this even further by saying that the atoms are actually positive ions and the electrons are delocalized or free electrons that are free to move or flow through the metal, and the flow of electrons is called the current. You would also get marks here for saying that the electrons carry the charge through the metal. You can also get 3 marks here from drawing the suitable labelled diagram. To do a diagram, we would draw our metal ions that are positive. You need to put them in a regular structure, quite closely packed together. And then you would include the delocalized electrons. Remember that you would need to label this to gain full credit. Right. An alloy is a metal which has some different types of atoms included in it. Okay, so it's a mix of metals, or some of them have got carbon added, which obviously is not a metal, and they have got quite distorted layers. So whereas the metal structure was in nice neat rows, the alloy is a little bit distorted, which means it's harder to push those layers so they don't slide across each other easily. That makes alloys usually a lot stronger than pure metals. Question 3C. Alloys are used to make dental braces and coins. Nitinol is an alloy used in dental braces. Why is nitinol used in dental braces? Okay, for this one, you need to recognise that nitinol is a shape memory alloy or a smart alloy, and it can return to its original shape. Question 3C2. Suggest one reason why coins are not made of pure copper. Do not give cost as a reason. Now, this links to what we said about alloys versus pure metals. Pure metals are normally a lot softer than alloys. Okay, so copper is a lot softer. You can also say it's malleable or it bends. You could also say that copper is running out. Question 3C3. Some coins are made from an alloy of aluminium. Complete the sentence. Aluminium is manufactured by the electrolysis of a molten mixture of cryolite and aluminium oxide is the word that's missing there. Question 3C4. Banks keep coins in polyethylene bags. These bags are made from low-density polyethylene. High-density polyethylene can also be made from the same monomer. How can the same reaction produce 2 different products? Now for this one, there's a few different answers you can give. You could say that there are different reaction conditions, there's a different catalyst, there's a different pressure, there's a different temperature, or there's a different concentration. Writing any one of those things down would get you the mark for this question. Question 3D. Give 2 reasons why instrumental methods of analysis are used to detect impurities in metals. Okay, so instrumental methods and 2 reasons. With this one, you've got to make sure you put 2 reasons down. Now you could choose from it's more accurate, it's more sensitive, it's faster, and it can use a small sample. Now you'll notice that this question is only worth 1 mark, and to get that 1 mark you do need to give the 2 reasons. Question 4. This question is about atoms and isotopes. Atoms contain protons, neutrons and electrons. A lithium atom has the symbol Li, 3 and 7. Explain in terms of subatomic particles why the mass number of this lithium atom is 7. Okay, so for this one, you've got to say that there are 3 protons, and we can tell this by the proton number or atomic number, and there are 4 neutrons, and the mass number is the total of protons and neutrons added together. You could also include in there, just for completion of the answer, that protons and neutrons have got a relative atomic mass of 1, although this is not needed for you to collect the 3 marks. Question 4b. Amounts of substances can be described in different ways. Complete the sentences. 1 mole of a substance is the relative formula mass in grams. The relative atomic mass of an element compares the mass of an atom of an element with the mass of an atom of carbon-12. Question 4c. 2 isotopes of oxygen are oxygen-18 and oxygen-16. Describe the similarities and differences between the isotopes. You should refer to the numbers of subatomic particles in each isotope. Okay, so we'll start with oxygen-18. It's got 8 protons, and therefore it has got 8 electrons. To work out the number of neutrons, we're going to do the mass number minus the proton number, which equals 10 neutrons. For oxygen-16, again, it's got 8 protons, and therefore it's got 8 electrons. Remembering that it's the number of protons that makes an element an element. If you change the number of protons, you will have a different element. So even isotopes need to have the same number of protons. It's only the neutron number that differs with isotopes, as we'll see now when we calculate this. We've got 16 and we minus 8 protons, which equals to 8 neutrons. So out of the 2 here, oxygen-18 is the heavier isotope. Both of them have got the same number of protons and electrons, but they have different numbers of neutrons. Question 5. This question is about compounds. Table 2 gives information about the solubility of some compounds. Okay, so we've got soluble compounds here. All potassium and sodium salts are soluble. All nitrates are soluble. Chlorides, bromides and iodides, except silver and lead, are soluble. Use information from Table 2 to answer these questions. Name a soluble compound that contains silver ions. Okay, so for this one, we can't have a silver chloride or bromide because they're not soluble, but we can have a silver nitrate. So what they want you to write in here is silver nitrate. Question 5a2. Name a soluble compound that contains carbonate ions. So here we have to look at the potassium and the sodium salts. So you could either put for this one potassium carbonate, or sodium carbonate. And either of these things would get you the mark for that question. Question 5b. Metal oxides react with acids to make salts. What type of compound is a metal oxide? It is a base. And a base will neutralise an acid to form a salt. Only when the base dissolves in water does it become an alkali. Question 5c. Lead nitrate solution is produced by reacting lead oxide with nitric acid. State how solid lead nitrate can be obtained from lead nitrate solution. So here you've got to talk about you have to heat it up and boil it, and then it will evaporate and form crystals. The next question, question 5c, is asking you to balance the equation for the reaction. So we need to have a look at what we've got on each side. Pb here, I've got 1. Pb here, I've got 1. Alright, then we've got oxygens here. I have got 3, and I have got 1, which is 4. Oxygens here, I've got 3, but I've times that by 2, so it's 6. I've got 7. Then we have hydrogens, I have got 1. Hydrogens, I have got 2. And then the last one is the nitrogens. I've got 1 here, and I've got 2 here. Right, so if I go through these now, my lead is 1 and 1, so that's balanced. My oxygen here is 4 and here is 7, which is going to be a bit of a nightmare to attempt to balance first. So make life easy for yourself. Do the simplest numbers, the ones where you can double up first. So for example, I have 1 hydrogen here but 2 here. So I need to have 2 on this side. So I'm going to put a 2 in front of my molecule that has hydrogen. Then I'm going to do a quick recount. I've now got 2 hydrogens, and I've timesed my nitrogens by 2. But I've also affected the oxygens. I had 3, now I've got 6 there. Add the one that's here, which is 7. And if I quickly just do a check through, it shows that I don't really need to do anything else for this one, because I've managed to balance the equation by putting a 2 in front of the HNO3. Question 5c3. Give the total number of atoms in the formula PbNO32. Okay, now there are 9 atoms in total in this. You have got 1 here, and then inside here you have got 1 nitrogen and 3 oxygens, which is 4, and that is being times by 2. So 4 times 2 equals 8, plus the 1 gives you 9. Question 5d. An oxide of lead that does not have the formula PbO contains 6.21 grams of lead and 0.72 grams of oxygen. Calculate the empirical formula of this lead oxide. The relative atomic masses AR of oxygen is 16 and lead is 207. You must show your working to gain full marks. So to do this, we need to work out the number of moles of lead and oxygen present in this new compound. By doing that, we need to work out the mass for each of them. So 6.21 grams is lead, and we need to divide that by the atomic mass of lead, which is 207. That works out at 0.03 moles. We also need to do the same for the oxygen. So we have 0.72 grams of oxygen divided by 16, which is the relative atomic mass. That gives you 0.045. Now obviously we can't really have 0.03 of an atom and 0.045 of an atom. So what you have to do is you have to find the simplest whole number ratio. So what you would do for this one is work out the ratio between these two numbers as a whole number. And it comes out at 2 to 3. Okay, so for every 2 of those, there are 3 of those. And because this one is lead, it means that I have 2 lead atoms. And because this one is oxygen, it means that I've got 3 oxygen atoms. So the empirical formula for this oxide of lead is Pb2O3. Question 6. This question is about sodium chloride and iodine. Describe the structure and bonding in sodium chloride. Okay, for this one you need to say that it's a giant ionic compound. Okay, it's got a giant lattice structure and it contains the ions Na plus and Cl minus that are held together by a strong ionic bond. Now it's very strong because the electrostatic attraction between positive and negative is very strong. If you wanted to here, you could also include a dot cross diagram to show the formation of sodium and chlorine ion, and you could also draw, if you wanted to, the lattice structure. Question 6b. When sodium chloride solution is electrolyzed, one product is chlorine. Name the 2 other products from the electrolysis of sodium chloride solution. Okay, so one of the products is hydrogen and the other one is sodium hydroxide. And you will get 1 mark for each of these. So 1 mark for saying hydrogen, 1 mark for saying sodium hydroxide. Question 6c. Many people do not have enough iodine in their diet. Sodium chloride is added to many types of food. Some scientists recommend that sodium chloride should have a compound of iodine instead. Give one ethical reason why a compound of iodine should not be added to sodium chloride used in food. Now for this one, it's asking you to give the ethical reason here. So it is about people having the right to choose, or there might be insufficient evidence of the effect on different people. Different people might need different amounts of iodine. Too much iodine could be harmful. And again, there are 4 points here that you could write down, but any one of them will get you that mark. Question 6d. The bonding in iodine is similar to the bonding in chlorine. Complete figure 4 to show the bonding in iodine. Show the outer electrons only. So both of these elements are in group 7 of the periodic table. So they've got 7 electrons in their outer shells. Okay, now electrons really like to go around in pairs. So we are going to put the pairs of electrons in now. So this iodine has got 1, 2, 3, 4, 5, 6 and 7 electrons in its outer shell. And our second iodine has got 1, 2, 3, 4, 5, 6, 7 in its outer shell. And now if we did a recount of the outer shell of each one, we will see that they've now all got 8 in the outer shell. So this iodine has got 8, 1, 2, 3, 4, 5, 6, 7, 8, and this iodine has got 8. Okay, so covalent bonding is the sharing of electrons in order to achieve that full outer shell. Question 6D2. Explain why iodine has a low melting point. Okay, so now for iodine, you've got to say that it's a simple molecule and it has got intermolecular forces between molecules that are quite weak. They require little energy to overcome. So although the covalent bonds themselves are really, really strong, it's the intermolecular bonds between the molecules. So say I've got 3 iodine molecules here. The intermolecular bonds that keep them together are quite weak. So they don't require a lot of energy to break. They will also accept if you want to say that they're small molecules or they've got a simple molecular structure. Do not say that the covalent bond is weak. Okay, the covalent bond is very, very, very strong, but it is only between 2 of the atoms. It's these intermolecular forces that are weak. Okay, so covalent bonds are very strong indeed. And now finally the last question, question 6D3. Explain in terms of particles why liquid iodine does not conduct electricity. Okay, so this is because the bonding in iodine is covalent, and that means that there are no delocalized or free electrons to carry the charge. If there is no charge to move, there's no current and therefore no electricity. And that brings us to the end of the question paper. I hope you found that really useful, and good luck when you sit in your real C2 exam. Remember, do not leave any answer empty. Please try and write something down. Okay? Make a really good guess about it. And with your 6 markers, if you can't write it in a structured logical order for your qualitative written communication marks, then just put bullet point facts. Okay, thank you and good luck.